Hello, Year 11. Welcome to the third lesson for exercise 10C, division of polynomials. This one you should have done it last year as well, but we're just going to refresh our minds, revise, and practice. So, do you actually remember how to change the improper fractions to mixed numerals? Because that's basically what we are doing for the long division of polynomials. So back in primary school, we remember to see how many 4s fit into 9. We know 2 wholes fit in. And if you fit it in 2 times, it leaves a remainder of 1, which you put over the original divisor, and we get 2 1/4. Now, the 2 1/4 means we add them together, right? It's 2 and as well as 1/4. That's basically how to change improper fractions to mixed numerals, but it's just a division. You're trying to divide 9 by 4. So if you replace them with polynomials, it's pretty much the same thing. But before we move on to polynomials, some of the words you might have to identify are the words to name each component in this division. So what we are dividing, we call the dividend. You're going to write this later, so don't worry. What you are dividing it by, so basically the denominator, we call it the divisor, which also appears here. What you get as a result, so this whole number, we call that a quotient. And if we had any remainder, we call it a remainder. So those are the proper terminologies we use to label each of the components in this division. And we are going to use the same words for the polynomial as well. So in this case, we say that the dividend over the divisor, or maybe I should write it down separately. I could say that the dividend over the divisor gave us a quotient plus the remainder over the divisor. So that's pretty much the format of how you change the improper fraction to mixed numerals. Or we could write the same result in a different way. As in we can probably say, to make up the dividend, as in your 9, you could have your result multiplied by the divisor, because that's how many times we said it could fit in, plus whatever you had remaining. So if you substitute the numbers I used above, we're pretty much saying 9 is 2 lots of 4 with an extra 1, right? 8 plus 1 is equal to 9. And we are doing the exact same thing with polynomials. So if you understand this logic, you should be able to understand the rest of the content. Okay, I think I've pretty much written what I have meant you to write in the next step, but if you've got a division, you need to memorize those 4 words. So dividend divided by your divisor will always give you a quotient, remainder of whatever. And usually you would write it like this in primary school, but instead of writing R2, now we learn to write the remainder as a fraction. So the advanced version of that would be fit it in 14 times, and if you have 2 remaining, it'll be 2 over 7. That would be the senior way of doing the fractions. All right, let's get into the real stuff, which is the polynomial division. We can also divide polynomials in a similar way and express polynomials in different ways. So for this one, we write the format exactly the same. So we want to write down our numerator, our dividend, inside the division, what do you call that? Division train? Bus? I know there was a cute name for it, but I forgot. And then what you're dividing by, the divisor, will go outside the train. And what we try to do is we try to match the divisor to the term that we see inside the train. Now how I do that is we try to come up with a term here where if you multiply these two together will give this as a result. So I'm asking myself, x times what gives me x squared? Well, I know x times x gives me x squared. So I'm going to write an x here and also write down the result I have here to check that it matches. And if it does, we move on to the next term. So now I ask x times what gives me negative 2x. Well, I know x times negative 2 will give me negative 2x. So I write negative 2 there. And I also write down the result. So x times negative 2 gives me negative 2x down here. Now it sort of looks like I'm just copying this down because I was trying to match it to the same terms. But if you look at more difficult questions later on, it will not match exactly. And that's why I'm telling you to write it down. Now, because I've matched the terms together, I know that the division is going to be x minus 2. Now this one you could probably just tell because if you divide that expression by x, you end up just cancelling the x's and get x minus 2. That's also another way to do it, I guess. But the long division method would be trying to match the term that you have. So then for the next example as well, you can take the shortcut and say, we'll just cancel out the x's together. I know I'm going to get 2x plus 5. But if you were doing it the long way, you were trying to match it to the next term. So I'm asking x times what gives me 2x squared. I need to multiply it by 2x, resulting 2x squared. And then x times what gives me 5x. I need to multiply it by 5. Hence, I get the result, 2x plus 5. So the answer to this division will be 2x plus 5. I'm getting no remainders, but if we had remainders, we'll have to write it in a different format. So let's see if we get there. I think the next one might be it. For this one, I can't just cancel out the x's because if I do cancel out the x, I can't cancel out anything there. So instead of doing that, let's get to the long division. Same thing, x times what gives me x squared? It's another x. Now, x times what gives me negative 8x? Negative 8. Giving me negative 8x. And then here's a problem. X times what gives me 3? Now, the result doesn't even have an x. So unless I times it by a weird fraction, it will not result in a constant term. So for this one, you will just have to stop at this point, and you are going to subtract away the terms that you had resulting, because that's what leaves a remainder of 3. 3 doesn't get subtracted by anything, so that is my remainder for that division. So as a result, I can write my quotient plus, remember how we used the mixed numeral? We used to put our remainder over the divisor. So that would be how you express the remainder term. 3 over x. That's your quotient. That's your remainder over the divisor. Let's do the same thing for the next one, if there is a remainder. Now a linear divisor with 2 terms this time. So this is where things get a little bit more confusing, but it's the same steps over again. To write my division, I'm going to have to go choo-choo train, dividend, divisor. Now if your divisor has 2 terms, don't worry about the second term. Just focus on the first term. And I'm going to keep matching it with my first term. So again, I go x times what gives me x squared. X times x gives me x squared. Now after you write that, it changes a little bit from here. Remember we wrote down our result here, x squared. When you write down your result, you don't only multiply the x with this x here, but you also have to multiply to positive 1. So the point is that you multiply it to both of the terms in the divisor. So I don't just get x squared, I get x squared plus x. So see how it's not matching anymore? That's because we were only focusing it on the first term. And then you need to subtract away both of the terms from your dividend. Actually, let's color code it differently. Let me write that as blue. Nope, it's not going to change my color. That's okay. So if you do x squared subtracted by x squared, because we have deliberately matched it as well, that's going to result in a 0, nothing. But this bit, I'm going to get negative 3x minus x, and that will result in negative 4x. Now the constant didn't get subtracted by anything, so that still stays there as negative 4. And that result is now what I'm going to match for the next quotient. So now I'm thinking x times what gives me negative 4x? Well, the answer is negative 4, so I'm going to have that on the top. And again, I'm going to write down my result to see if there's any remainder. So x times negative 4, negative 4x, that should match. And then I do positive 1 minus 4x. Oh, sorry, positive 1 times negative 4, which is negative 4. So this one, thankfully, it matches completely. So if I subtract away these terms, I'm subtracting the exact same expression, so I get left with 0, which means there is no remainder. So I can say that the result of this division is just my quotient, x minus 4. Full stop. How about the next example? For this one, we do the same thing. Choo-choo train, dividend, divisor. Match the term again. X times x will give me x squared. Oh, I can change the color. And I'm going to have to multiply it by both x and negative 1. So I get x squared minus x. Subtract that whole thing from your dividend. Then I get x squared minus x squared, nothing. 5x minus negative x. So that's 5x plus x, which gives me 6x. The constant stays as minus 7. And then I think x times what gives me 6x, positive 6. And that is what you multiply to both of the terms. So I get 6 times x, 6 times negative 1, and subtract that whole thing from whatever you had remaining before. So 6x minus 6x, of course nothing. Negative 6 minus negative 6, minus 7 minus negative 6 would be negative 7 plus 6. So that gives me negative 1 as a result. So I know it seems a bit weird, but because we're dealing with division of polynomials, we can have negative remainders. So as a result, I use the same format again. It'll be my quotient plus my remainder over the divisor. So I guess you could write it like that, or just write it as x plus 6 minus 1 on x minus 1. If you don't want to have a negative on the top, same thing. Or I don't know if you remember the second form that I wrote it in. I could also say, so I could write down the same results, but as my dividend being equal to my quotient times my divisor plus my remainder. And adding negative 1 is the same as subtracting 1, so I just wrote minus 1. But that's literally the form that I had before with the 9 divided by 4. How I wrote it like this. That's the same format. So same division, but you can write the result in 2 different formats. And this format is actually going to be more helpful for you later, because see how you've got a little bit of a factorization here? It's going to help you heaps with solving the polynomial or graphing the polynomial. But I think that's going to come out in a later exercise. Okay. Now this one, non-monic. I'm trying to go through an example that's of different types. So for this one, it's not letting me change the color again. For this one, same thing. Choo-choo train, dividend, divisor. Match the terms. X times what gives me 3x squared? 3x. Multiply it with the divisor, so I get 3x squared plus 6x. Subtract it away, then you get 4x plus 2 as a result. Next step, x times what gives me 4x? Plus 4. Multiply the result, 4 times x, 4 times 2, subtract, negative 6 as a result. So in this case, I could write the division as my quotient minus remainder over the divisor. Sorry, I should have said plus remainder, but my remainder is negative, so I wrote that as negative 6 over x plus 2. Hopefully this is coming along together, but we just need to do lots of practice with long division. It's very easy to make a silly mistake. I asked a long division question on ChatGPT the other day and it got it wrong with its own coding program, so there you go. But we won't make any mistakes, would we? Choo-choo train. Now this one is a cubic. Now for the cubic polynomial, see how it's missing the term with a quadratic term? It's got x cubed. And it doesn't have any x squared, it goes straight to x and then a constant. In that case, could I recommend you to leave a space for the quadratic term? So leave a bit of a blank space and then write negative 11x plus 5. Or I know some people even like to write plus 0x squared, and that's because if you don't have all the terms in that order, you might make a silly mistakes. I'll show you what I mean by that. So if you were to do it normally, oh, okay, now it's making me change the colors. I will change this to a darker color. Okay, that's much better. Divisor is x plus 1. Okay, match it again. X times what gives me x cubed? X squared. And if I multiply the terms out, it'll be x cubed plus x squared. So see how I end up getting a quadratic term from that multiplication, but because I don't have any quadratic term to subtract it away from, when I do this step, I will sort of form a quadratic term that wasn't there before. So the cubic terms are gone, but if I subtract an x squared, I'm going to get this as a result, and those two terms just get brought down because there's no other terms. And if you didn't have that gap, the mistake that people could have made is to subtract this from this term, but they're not like terms, so you shouldn't be able to subtract them. But if you had them in the same column, it's very easy to make mistakes like that. Anyways, we continue the same step. X times what gives me negative x squared? Negative x. And if you multiply it with the divisor, you get negative x squared minus x. Subtract it. You will get negative 10x because you're adding x plus 5. Match it again. X times negative 10 would give me negative 10x. Multiply with the constant, I get negative 10. Subtract it away, I should get 5 plus 10, 15. So that's my remainder, which means my result this time will be a quadratic plus, remainder over divisor. it will get very repetitive. So once you get the gist of it, it shouldn't be too bad. Okay, there are practice questions which you can try in your own time. It's got up to quartics, so good luck with that. Now this one, I've already talked about it, but there are two ways of expressing the division. One way is to write it as a dividend divided by divisor is equal to quotient plus remainder over divisor. We've been doing that for the previous division questions. Or you can express it in the multiplication form where you say the dividend is equal to your divisor times the quotient plus whatever was remaining behind. And I did say that the second format is going to be better for your algebra, but it doesn't hurt to practice both ways. So using the same expressions, I'm just going to name some of the components as polynomials. So we're going to call the divisor d of x, we'll call the quotient q of x, and then rx as our remainder, and p of x is just any polynomial, which is going to be pretty much our dividend. So you can see that the format is exactly the same as what we had here, but one's just in words, one's in mathematical expression. So have a look at the example. Use the polynomial divisions to express it as this format. Well, we're going to have to try the long division first, so let's do it on the side here. X cubed minus 4x squared plus 2x plus 5 divided by x minus 2. Match the terms. X squared, that's going to give me x cubed, which matches, minus 2x squared. Subtract it, you will get negative 2x squared with remaining terms. Matching to negative 2x squared, I need negative 2x, giving me negative 2x squared plus 4x. Subtract it away. You will get negative 2x plus 5. Last one, I need to multiply by negative 2 to get negative 2x plus 4. Subtract it away. I would get a 1. That's a small remainder. So then I should be able to express this division as my quotient plus remainder over divisor. That is literally what we have been doing in the previous questions. So I hope you can do part B by yourself, but it is a trinomial divisor, so good luck with that. That could be a little bit more difficult for you guys. For example 2, they want you to express the answer in the second format. So let's try the division. For the first one, it's a choo-choo train with a cubic. Now I can see that the quadratic term's there, but the linear term's missing. So I'm going to leave a bit of a blank and write negative 5 here, so I don't make a mistake. Divided by x plus 3. Match the terms. I know I have to times it by 2x. 2x squared plus 6x. Subtract. Negative 2x. Oh! Why? Why did I write that as squared? That should be cubed. That should be squared. That should be cubed. That should be squared. My bad. So that should be negative 2x squared then. Minus 5. Still a bit of a gap there. Now x times negative 2x will give me negative 2x squared minus 6x. So that's where I'm going to write it because I don't have any linear terms to work with. Subtract. And I would get 6x minus 5 left over. Finally matching to positive 6, I'll get 6x plus 18. Subtract it away, I will get negative 23. What an awkward number. So then, for part A, I can say that it is equal to, oh no, I shouldn't say that's equal to. I should say that the dividend is equal to my quotient times the divisor plus negative 23, so minus 23, which is my remainder. You guys can try part B by yourself. It's still a binomial, so I don't think it's too bad. Example 3. I think that's the last one for today. This was a long video. This one tells you to simplify the division, hence solve a quartic equation. So how on earth are we meant to solve a quartic? Now you can, because you can divide polynomials, which often helps you with factorization. So we're going to do the same thing. Choo-choo train. Choo-choo. Choo-choo. Plus 9x cubed minus 5x squared minus 6x plus 2. A bit long, but let's try. Now this one is a quadratic factor, so it could be a little bit more confusing. So hopefully you will be able to follow. Okay, 3x squared matching with 3x to the 4. I need another x squared, giving me 3x to the 4 minus 2x squared. Notice how it doesn't match with the cubic, so I'm just going to move the term to the column that it belongs to the quadratic term column. Still subtract it away, then I will get 9x cubed minus, no, it's a plus 2x squared, so I'll get minus 3x squared minus 6x plus 2. Matching again, I'm going to need plus 3x, which gives me 9x cubed minus 6x. Trying to put it in the right column. That's going to give me negative 3x squared, cancel away, plus 2. And to match that, I need a negative 1, which gives me negative 3x squared plus 2. Now that matches perfectly, so that's going to give me remainder 0. So the division is going to give me x squared plus 3x minus 1. Now if the question says hence solve that, because it leaves no remainder, I can say that this polynomial on the left hand side, which is the same as this one, that should be equal to this divisor times the quotient. So now I can rewrite this equation as your divisor times the quotient is equal to 0. And voila, we've actually factorized it. And it's a quadratic and a quadratic, which means we can just solve it separately. So the first one I'm going to solve for is this is equal to 0. Very easy. Move the 2 and divide by 3. I know x squared has to be plus minus root 213. And then this bit, I'm solving it on the right hand side. X squared plus 3x minus 1 is equal to 0. I don't think you can't factorize that. Let's do a quadratic formula. Minus 3 plus minus b squared minus 4ac over 2a. And that is, that's root 13, and that's not simplifiable, so that must be it. So we've got 4 solutions in total. So using long division, you can now solve polynomials of higher degree other than quadratics or simple cubics. For the homework in this exercise, you will try this worksheet attached on the bottom of the page. So you can hop on to Cambridge if you want extra questions, but doing these questions should be enough. And the answers are on the bottom as well for you to check. That's it. It was a long video. Well done, guys. I will see you in the next video. Bye.